In this presentation, I am dealing with the second half of the crystal defects, that is line defects and plane defects. And line defects, an imperfection occurs when the periodicity of the atomic lattice array is interrupted along certain directions in a crystal. Such interruptions occur along rows of a crystal structure and are called line defects. The most common type of line defect is dislocation. There are two types of dislocation, that is edge dislocation and screw dislocation. And coming to edge dislocation, it arises when there is a slight mismatch in the orientation of adjacent parts of the growing crystal, resulting in the introduction of an extra row of atoms. The edge of the atomic plane terminates within the crystal instead of passing all the way through. Under the impact of the shear, the dislocation moves across the crystal in such a way that top half of the crystal is displaced one lattice distance with respect to the other half. And next is screw dislocation. In screw dislocation, it can be visualized by cutting a rubber stopper parallel to the axis and pushing on one end so that a jog is created on the other end. If initially the stopper contained atoms at regular lattice points, deformation would convert the parallel planes of atoms normal to the axis into a kind of spiral ramp. And such displacement of atoms is known as screw dislocation. And the important point is that in screw dislocation, motion is perpendicular to the direction of stress. And next is plane defects. And plane defect arises due to the discontinuity of the perfect crystal structure across a plane. And there are three different types of plane defects: grain boundaries, twin boundaries, and stacking faults. Coming to grain boundaries. Internal surfaces of a single crystal where ideal domains meet with some misalignment. There are two types of grain boundaries, that is low angle grain boundary and high angle grain boundary. In low angle grain boundary, misalignment is in the order of few degrees, that is less than 10 degree. And in high angle grain boundary, this misalignment is in the order of higher degrees, that is greater than 15 degree. And this low angle grain boundaries are of two types, that are tilt boundary and twist boundary. If the low grain boundary is formed by edge dislocation, it is called a tilt boundary. And twist boundary is formed by screw dislocation. And next is twin boundaries. Twin boundaries are in which the grain at which the atomic arrangement on one side of the boundary is the mirror image of the atoms on the other side. And the region between the boundaries is called twin region. And it is also produced by shear deformation. And the next one is an extended plane defect, that is stacking fault. It occurs in materials having layered structures. For example, consider the crystal lattice of FCC, that is face-centered cubic lattice, and the arrangement is of ABC, ABC, ABC pattern. But in this example, we can see that in the second line, there is that letter written in red color, that is A, that is missing. That means ABC, ABC pattern is not following, and also AB, AB pattern is also not following. So, and this is called stacking fault. And this type of defect is exhibited by cobalt, graphite, etc. Thank you.